Well, hello. Welcome, everyone. My name is John Petsy, and I'm with Sky Foundry, where I'm a co-founder of the company. Our focus is data analytics, and so what we want to speak to you today about is the role that analytics play in achieving efficient, data-driven facilities. And this is a comment we like to make that your building systems have something to tell you. They have important information, but you have to be able to speak their language, interpret that information that they provide, and that's the role that analytics plays. Analytics for buildings and building systems, what are we talking about when we use those terms? Well, analytics, the concept is quite simple. We're going to use software technology, and it's going to detect patterns that are in the data that our equipment systems are producing. Those patterns could represent outright faults. They could represent just deviations and anomalies from expected performance. They can represent correlations between different systems and events. But here's what's important. They all represent opportunities for improved performance, greater efficiency, and financial savings. And what we like to say is that analytics automatically finds the things that matter in your data and then presents them to you in a way that's clear and understandable and allows you to take action. So let's dig in a little deeper. First, I think it's interesting if we have a perspective on how data and analytics are changing our entire world. Here are some quick news articles. Analytics is being used across society. I would venture that all of us, while we're talking here and listening, you're being subjected to analytics. If you have a smartphone, you are. If you're on a network, you are. There's data about you that's being used. Now, hopefully it's being used in good ways. And here are ways that organizations are using analytics on their data that they have the right to get from their customers, their populations, to improve, whether that be the crime situation, the relationship with customers, sales effectiveness, etc. And the point here is it can change our buildings too. Analytics, specialized for buildings, can dramatically change how our buildings work. But it's a reasonable question to ask, why do we need it? I walk into my building every day and everything's okay. Well, there are a number of reasons that we need to utilize analytics on our facilities. And underlying it all is this issue. Buildings are very complex. They're very diverse and different. And there's sophisticated systems that operate them and maintain the internal environments. Systems that come from different manufacturers and interact in different ways. So it leaves us with the question, do we know how our building systems are really operating at any point in time? Well, why do we care? The first thing is that we want to reduce our operating costs, right? We don't want to waste money. So if we understand better our performance, deviations, anomalies, problems, we can reduce our operating costs. Increasingly, we need to meet regulatory requirements. The built environment is subject to numerous regulatory requirements, and that directly relates to the increased societal demands around energy and or environmental and sustainability and governance goals, ESG. There's also an important financial reason. Good performing facilities have a higher asset value and produce greater cash flows. And studies have borne this out, independent studies, including research by the Carbon War Room and numerous others by BOMA, the Building Operating and Management Association. More efficient buildings, all other things being equal, have a higher asset value and higher net operating income. So those are some pretty good reasons to care. But now the challenge, right? I've already got technology in my buildings. I have a computer-based building automation or building management system, and it's working, so things must be running properly, right? Well, just because we have a computer-based system doesn't mean that it's doing the right things. There's a lot of factors involved, right? who would be watching in your organization to make sure that the things that computerized system is doing are the right things? That the control strategies they're executing were well and properly designed? That the assumptions they were based on were and are still correct? Have we changed systems, changed usage of the building, changed the load on the building with more people, more computers, data rooms, etc.? And then, are they still operating as we expected? Have they been interfered with? Have they been overridden? Has equipment degraded? Have sensors degraded and valves degraded and fan systems and other things degraded? All of these things would affect whether our buildings are really running optimally. But the problem is, buildings are simply too complex for all of these things to be continuously assessed by human beings. There's just simply too much data. The systems are too complex. So we need tools. But what we really need, if we want to describe it as a person, is some person who would be constantly watching the operation of all of our systems, all of our sensors, all of our equipment, all of our devices every second of the day, and comparing what they're doing against the design goals, the expected operating profiles, the expected performance, and then automatically creating detailed, informative views and reports to show when things deviate, when issues are found, when faults are found. That's what we'd all like to have. Well, it's not someone who does that for us. It's analytics. That's exactly what analytics do for us in the built environment. With analytics, the result is that you have a system, you have software that's constantly and automatically processing rules and algorithms on your data so that you know how your systems are really performing, not how you might hope, not how you were told they would, not how the specifications said they should, but what they're actually doing. That engine continuously runs against the data to detect patterns, behaviors, correlations. But then it takes the next step, which is very important. When it finds issues, it automatically generates views for the operators to show them the fault patterns, the correlation patterns, the behaviors, the deviations. And this is key because this is one of the ways that analytics has made this cost effective. If, for example, if we had to assemble a report or draw a graphic or create a web page for every possible finding in complex building systems, we could really never make analytics cost effective. But the software is smart enough nowadays to automatically create a whole series of views on the issue detected, enabling you to dig down to the root cause, the actual sensor values, the time these changes or patterns emerged. Another key thing about analytics is that they're always there. You write an analytic rule once, it identifies a problem, you correct the problem. If that problem comes back 2 years later or further, that rule is sitting there waiting to identify that, create the view, inform the operators. Because building systems do degrade. They're mechanical systems, they're electrical and electronic systems, they do degrade. Another important advantage of analytics is for the practitioners, whether you be a system integrator, energy consultant, M&V professional. These tools will now convert your extensive domain knowledge. They're a platform for you to convert your extensive domain knowledge into rules, actually building up your library so that now your domain knowledge becomes automated. So your value builds with every project you do, every rule you write, every system you analyze. You're building value in the platform, making it deliver greater and greater value. So what are we talking about? Well, we certainly haven't got time for an exhaustive list of the things that are found in buildings, and I think you'd find them pretty amazing, some of the problems and deviations found in buildings. But here are some common ones that will hopefully drive the story home. Simultaneous heating and cooling. That happens. It's not an uncommon problem. It can happen in a single HVAC unit for a variety of reasons. You could have a programming error. You could have a sensor that goes bad. You could have one of those valves that won't close off, right? The heating valve won't close off as we enter into the cooling season, right? So we're passing in heat energy while we're trying to cool it. But there's also another interesting example we call group heating and cooling in a, for example, a big box retail store with 10 HVAC units. What if one of them is fighting the others. 9 of them are cooling on a hot summer day, and 1 is fighting the others due to a sensor problem, a programming error, or some other type of mechanical problem. It happens, as does short cycling, lack of diversity control. These are all real examples of things that are faults, if you will, that waste energy, waste costs, waste money. A lot of things we use analytics for are directly related to energy. And here's the value that analytics provides, right? There's been energy analysis tools around for many, many years. The problem is the human has to sit there and work them. Well, with analytics, it'll automatically calculate your energy intensity metrics. And then it'll compare those against your benchmarks or baselines or goals or industry standards. And then it'll tell you what you need to know, automatically taking you to the end result. Right? When did I deviate? Exactly what time? How long did it last? How often does this occur? How much do we deviate by? And it'll even turn it into cost. And on the subject of cost, it has the capability of actually calculating cost based on true complex energy costs, or what's called tariff rates. Now, a lot of things SkySpark Analytics are used for fault detection on equipment systems. And I like to bring up this example because it gets to one of the key interests of a lot of building owners, predictive, right? Can we predict faults? Well, most faults are preceded by some types of pattern. Here's a simple example, but a real one. Degradation, the trend of degradation of cooling or heating performance, the loss of efficiency across a cooling coil or heating coil, that can be tracked, identified, the rate of change found, and it can actually inform you that you're going to have a problem here. You're not going to be able to meet your load requirements, meet your comfort requirements. It hasn't failed, but it's not going to be able to perform for it. Now, of course, there are outright failures. Economizers open is a good example, open when they shouldn't be, or closed when they should be open. Right? Economizers can provide great energy benefits, but they can also provide tremendous energy loss if they're not performing correctly. Non-functioning sensors. This is interesting because people often think, well, I'd know if a sensor wasn't reading right. Well, the reality is that's not that simple. Non-functioning sensors have surprising and hidden impacts, but the patterns of non-function or out of calibration can be detected by software analytics. And then there's outright faults, right? Lights and other loads operating when they shouldn't operate, right? Maybe if you were watching every system every second of the day, you'd detect that. But the reality is we don't have that luxury. Set points get overridden. Schedules get overridden. Do they ever get put back to proper operation? The most important point here is that all buildings are different, so analytics can be tailored to the reality of your buildings. There's lots of standard analytic functions, but all buildings are different. What might be proper operation in one building is improper in another. They need to be able to be programmable, configurable. Well, those are some examples of faults, but you know what? Analytics provide a lot more benefits than just fault detection. For example, automatically calculating, tracking, and reporting your KPIs, your key performance indicators, and showing you the trends so you can see degradation in those trends. You can manually look at them to see what's happening and draw insight from them. A lot of the benefit is related to energy analysis and reporting. Increasingly, organizations are required to report data so it's compared to industry standard benchmarks or requirements. Well, the analytics can automate all of that for you. And it can go further. Normalize your energy data for factors like weather, occupancy, production activity. It can help you combine energy uses with tariff rate charges, as I mentioned, to calculate your true energy costs. And then there's the whole point about visualization. Visualizing the data that you never really saw before, so you can see the patterns in your energy use profiles. You can see where you have demand peaks. You can see your usage history. And a big part of the benefit is related to, as I mentioned, organizations being more aware of ESG goals, calculating greenhouse gas, converting your energy usage, no matter what the resources are, whether it's oil, gas, water, electricity, converting it to greenhouse gas equivalents so you can do the necessary reporting that you may need internal in your organization or external for regulatory bodies. And reports are a big benefit, right? All of this data overwhelms human beings, but if we can turn it into clear reports, we can deliver important information to our operators, our energy managers, and our financial managers. And on that subject, analytics can automatically post your energy data to government agencies, eliminating hours of manual effort. In the U.S., many buildings over a certain size are required to report their energy use to Energy Star Portfolio Manager. Our software technology would do that for you automatically. And on the subject of analytics beyond FDD, there's a positive side. It isn't just about finding problems. How about being able to clearly and consistently report that you're achieving proper operation? This is a risk management issue. You can confirm that you're providing the occupants comfort, safety, air quality that is required by your leases or commitments you've made to your occupants. Right? That's a very important thing to do. So we're not just talking about finding problems. We're talking about confirming, building confidence, verifying. And in order to do that, you often need to report in standard formats, PDF, Microsoft Excel, and others. The software lets you do that with a click or even automatically. Now, on the side of energy and investment in energy conservation measures, there's a concept called monitoring and verification. And there's a standard for that, the IP MVP protocols. Well, the software streamlines your whole process of doing M&V in accordance with those protocols, reducing the cost, improving what you can do, and making it continuous and ongoing. It's called monitoring-based commissioning. Now, all of this data can feed other value in our organization, helping the operations staff justify expenditures, justify budgets, justify proposals for capital expenses. Because now you can calculate your operating costs based on real tariff rates, and not just once a month, but continuously, every interval meter reading. And you can calculate the impact of the issues that have been found, the faults, the deviations, and put that all in reports. And when we talk about reports and communicating with the other people in our organization, one of the big challenges is bridging the gap between operations staffs and financial staffs. Well, being able to produce these reports in standard formats helps us bridge that gap because we can deliver the information in a format that speaks to financial managers. And another important trend is what's called automated system optimization. With analytics, we can have our controlled decisions and algorithms based on deeper insights than are possible with typical control systems. And with two-way communication, we can get the data. The algorithms can make decisions to go in and modify operating parameters like set points, like schedule times, and other things based on a variety of advanced analytic tools, regression analysis, machine learning, and others. So, that's the benefit. How does it work? Well, the basics. Step one is to connect to data. We've got these different systems in our buildings, whether it's a building automation, or building management, or industrial automation system. That's a source of data. And I want to point out, it might be a live streaming source of data, or it might be one that can only provide batch data. It's still valuable. You can do tremendous amount of analytics with data that's delivered in batches of historical data. So you can start without having to connect live to your different systems. And then there's facility and asset data. This is important for our normalization and correlation, like the size of a building, so we can normalize our energy use. The type of construction. Maybe we have multiple types in our portfolio. That way we can compare performance against type of construction and other characteristics, like the brand of equipment used. Now, of course, we want to have utility data, but here too, that might be a smart meter from the utility company. It might be a web service feed from the utility company, or it could be a sub-meter connected into your automation system, or it might be years of historic energy data in Excel or CSV file formats. It works with it all. And then there's weather data, which affects the operation of the building. Well, what we've done is we've built a weather data feed from a worldwide weather service into the software. It has more weather data than most buildings are ever instrumented for. And we don't want to forget production data. What are the facilities production metrics. What's it used for? If it's a factory, it's the number of widgets produced per shift or per hour, right? And we can calculate the energy content. But if it's a hospital, it might be the number of beds that are full. If it is a office building, it might be the amount of square footage that's leased and actively occupied. If it's a chain of restaurants, it might be the revenue per site, because a busy restaurant consumes more energy than a not busy restaurant. So we like to say it's easy to get started. You have data, find it, and determine, how can I connect to it? Real-time data, historical data, the software works with it all. A key part of working with data is this, though. It's giving the data meaning, descriptors. For example, if I read a number out of a system, I need to know, what's that number represent? Is it degrees Fahrenheit, or is it kilopascals, or kW or kWh? That's an example of a simple way we give data meaning, but it goes beyond that. We want to capture dimensions, units, relationships, associations. Which schedule is associated with this air handler or piece of equipment? Sorry about that. So we tag the data, and we utilize an industry standard called Project Haystack. It's the most adopted worldwide standard to tag data, to mark up data, to add what's called semantic meaning or metadata to it. Now, there's automated tools to do it and manual tools to do it, but it's part of the process, because this helps us normalize all the data from, again, these different systems. Now, once we have data, then we can define rules and KPIs, or we can choose. What we've done is combine an extensive library of analytic functions with full programmability, because all buildings are different. Now, here's a simple rule, but a real one. It has a name for the human being. That's for us to understand it, simultaneous heating and cooling. And then it says we run this rule on anything that's been tagged, defined as an air handling unit. And then there's the rule function. In this case, we're saying look for a period of intersection between the heat indicator being true and the cool indicator being true, whether it's a valve or an electric coil or some other method of heating or cooling. The result, we get a spark, and as we saw earlier, the software automatically generates views to show us those results, their timeline of operation, correlations with other sensor values, energy usage, etc. But the last mile is related to that, the views. How are we going to deliver the information to the operator? Because data analytics are only valuable if they help drive the process to address issues. We like to say analytics finds what matters, but those things require follow-up. They require some type of action, whether it's be correcting a software problem or maintenance and repair on physical assets. So the visualizations are key. And it's important that if the process to create these views and visualization involves significant costs and effort, then the value we get from analytics will be diminished. So this is a huge area of investment in development. We've created a unique user experience, a set of solutions, automatically generated apps and views, easy assembly of custom apps, the ability to report anything you see on the screen with a click, turn it into a report, PDF report, a graphical view, etc. So we have a whole suite of tools that brings us to a wide range of user presentations to fit different user needs, whether they're focused on energy, KPIs, faults, etc. But then there's a question, a valid question. Okay, this all sounds great, new technology, but does it work? Well, this is what's important here. This is highly proven technology. Our software from our company has been deployed to over 1 billion square feet worldwide, over 18,000 facilities on 6 continents. So it's proven, and it's independently validated. There are numerous case studies. We're happy to be the beneficiary of numerous case studies generated by external organizations, U.S. Department of Energy's Better Buildings program, along with other case studies here produced by the end customer. So there's lots of proof points of how analytics truly saves money, improves performance, improves health and comfort of buildings and facilities. So I'd like to leave you with this comment as the end. Data, it's a new form of money. It's a new form of value. Of course, we need to the tools to work with that data, and that's what analytics does for us. So our company is Sky Foundry. Our software is Sky Spark. It's a leading analytics solution for the built environment, as I said, deployed to over 1 billion square feet. We'd be happy to follow up with you and help you understand more about it, more about the process of deploying it, more about all of the proof points out there, the case studies, the success stories, etc. Thanks for your time. I hope it's been helpful. Again, my name is John Petsy, and we'd be glad to follow up with you. Thanks again.